Hello everyone, and welcome to the 5th webinar in 12D's training webinar series. My name is Lisa Stewart, and I'm the Marketing and Communications Coordinator here at 12D Solutions. Our 12D training webinars will showcase common industry challenges, taking a close look at industry best practices and how these can be implemented using 12D model software. The aim of these webinars is to upskill 12D model users and broaden their understanding of the capabilities of 12D model. We also run regular training courses all around Australia and New Zealand. See our website for more details on these, or indicate in your post-webinar survey that you'd like to be contacted about this or in-house training. We'll keep running these webinars regularly and recording them for posting on our website and on YouTube. Our first 4 webinars from this training series, as well as the first 9 webinars from our Industry Solutions series, are already available online if you missed those. During this live presentation, you'll be able to type your questions along the way, as shown on the screen, and we'll answer as many as possible throughout the webinar. At the end, I'll also read out some of your questions to the presenter for his insights if there's time. Today's webinar on layered subgrade for construction will be presented by David Owens, who has 30 years of experience in design of civil infrastructure, including roads, drains, parks, sports fields, and landfill for Brisbane City Council, as well as 18 years of experience as a 12D user and 8 years as a 12D trainer. This webinar from the training series will demonstrate using layers in MTF modifiers as construction lines to build up surface and subsurface models. Over to you, David.
Yes, thanks, Lisa. Good morning, afternoon, everybody. So this little session came about simply because I had a few interesting little problems that I was trying to solve in some recent projects, and quite frankly I thought some of these little techniques might be worth having a look at and worth sharing. So the 3 examples that I'm going to use to show some of the things that I found out was looking at creating stepped type pavement layers where one sort of overlaps another one a little bit, creating a cut-off wall or a trench, depending on what it is you're trying to model, but I had to do a cut-off wall in a project, and even modelling up some little block retaining walls. So with the road pavement project, this is where I'm actually trying to head towards, is being able to create models of my different pavement layers at different sort of steps or offsets. So I've got my MTF editor up and running already, and I'm just going to do a couple of things on the left-hand side of my alignment. This has been seriously cut down from the actual project just to demonstrate a few of these things. Before I get into the modifiers themselves, just showing how I've got a few little blue lines just drawn perpendicular to my road here. I'm a big fan of the new alias definitions within the modifiers for defining start and end changes. So what I tend to do is actually draw the start and end of extents of various things that I'm doing around the design. So in this particular instance, I have aliases defined for the full extent of the project, which is defined by wherever my centre line, my reference string cuts through these little lines that I've drawn. And then as you start to build up the design and you realise you need to introduce a few other things, so in this case I had a couple of areas of road widening rather than just full pavement. Again, simply by drawing a couple of lines and saying wherever those lines intersect with a reference, that's where these different areas are going to start and stop. So I reuse these start and end changes throughout the course of the project. Okay. So to get where I've got so far, as you can see on the view here, I've got my design surface in. Pretty simple standard stuff. Everyone's seen this sort of thing before about inserting some basic templates, maybe doing some modifiers to some of the surface strings, adding in my curve and channel and bird shape. So that's all good so far. Okay. Now, so the reason for this demonstration was talking about using different layers that are available in the MTF to create sort of construction lines, as it were. And one example, before we even worry about looking at pavement layers, is even on the surface itself. Okay? there are times when you may want to do modifications to certain parts of the template, of the surface, but then you want to be able to put the other parts back to where they were supposed to be in the first place. Yeah? So in this example, I'm putting in a, excuse me, I'll just make that active before I do that so I don't lose it. Putting in a little construction line on a layer called construction of verge, matching my first footpath link with a 0 width, 0 height. Okay? You'll also notice I tend to recycle link names so that I know which links are supposed to line up with what. The fact that they're on different layers means that they're different information, they're different links, but at least I know what part of the cross-section they're relating to. But the reason for this one, just not down here, I'm just throwing in a very rudimentary dummy sort of driveway. I'm not saying this is a proper driveway design, but this is the sort of thing that can happen. At times when I just want to drop the height of the top of the curb link to give it a section where someone could actually drive into a driveway. So modifying the height down to a height of 0, keeping it 0 for a distance, then coming back up again. I'll just apply that. Okay. And profile one of the offending cross sections. Oops. Yes. So by dropping the height of the curve down to 0, everything that follows that has still got its original relationship of a 2% slope from that top of curve out. But I'd like to be able to put that footpath levels and verge levels back to their normal position. So in my modifiers then, with a modify absolute command, I'm saying that my first footpath link, I want it to go back and match onto the construction line that I've put in this construction verge layer. Again, modifying the height but with the difference of 0. So when we pop that one back on and apply it, and profile that cross section again, it puts that footpath point back up to where it was supposed to be in the first place. So the beauty of that is it doesn't matter exactly what alignment that footpath string was running on. The width between it and the curb could have been changing, the height could have been changing, just matching back onto whatever it was before I started playing around with that top curb. Yeah? So a simple little use of a construction line there. Okay. All right. Taking this a little step further then, as we start getting into boxing definitions, there's always a few little sort of setup things we need to do to get running. First one being a named grade. So defining what the slope of my road surface is between my hinge, my centerline, and the carriageway edge out on the left, the CEO length. Because we're going to be intersecting all sorts of things using the slope in a minute. Okay. Another one that we need to put together, again, is a kind of a construction thing. It's more for the construction of the tri-meshes a little bit later on. Just need to duplicate that hinge string with the link that I can include in those shape commands. Okay, so the first simple little one, and something that's quite common, we've all done this probably before, but just going to insert some links to represent the base of my curve and channel. First one just being directly underneath the carriageway edge on the left. Okay. Sticking it in another layer, say this is my curve on my left hand side. Okay. That's all very good. Second one being an intersection of two links. Once I've created my point directly underneath my carriageway edge, the next point I'm looking to create would be an intersection of that new point horizontally and the back of my curve vertically. The reason I go for an intersection rather than a simple insert is that then if my curve profile, if the width changes or if the height of my back of my curve happens to change, it doesn't matter, this new point's always going to be created in the correct spot. And then with our shape commands, it's simply a case of joining all those points together. So we've got points in our design surface, from the carriageway edge, inverted curve, top, back, and then down to my new points in my curb layer, again, back a curb and carriageway edge. Okay. Again, notice the recycling of names so I know which point lines up with what. Okay. And simple apply. And we have our curve shape. So again, as you can see with the intersection, it doesn't matter that this particular curve has a different height for my back. As I step through to a full height curve, the base is still being created in the right spot. Okay, now that's the simple stuff. Now on to the actual thrust of what it is I'm trying to achieve today, using construction entities to build up these pavements. So what I'm actually going to do is effectively create a grid by inserting construction points at the depths of the various layers of material. Okay, so for example, I can do an insert absolute on a construction layer for the depth of my DG14 layer, might be 100 millimeters below my design surface at the carriageway edge. Okay. And then similarly for the other layers of material. So I could have my DG8 might be 150 mil below my DG14 construction point. I might have a cement modified base layer, for example, another 150 mil below that DG28 layer, and a type 2 subbase, for example, another 150 mil below. Okay. So these heights that I'm putting in here are just sort of randomly selected heights, just to demonstrate how we can construct these grids. Okay. The only other little thing with using different layers within your MTF is you have to have a command to store these as real strings in the model so you can see what's going on. So down towards the bottom of my file here, I've got a couple of create string commands that I've sort of left active for the moment. That on my construction model, I'm going to put all the links that I've added to my construction layer so I can just see them get created. And then I can use my middle mouse button to simply pick them when I need them later on in other commands. Okay. So when I run this apply now, I've created a little sort of vertical part of my grid with points at my different pavement depths, thicknesses. Okay. Now, some of the other construction would be potentially having to create a few points that are coming out behind the back of curb point. Okay. The same situation, inserting on a layer. This time, link name is a little bit different to the original, so back a curb left, but with whatever the offset distance is. In this case, I'm going to go 150 mil for my first point. Relative to the base of curb, back a point, mainly because that then gives me a point that's ready to use in one of the pavement shapes that I'm going to build later on. Probably doesn't matter a huge amount exactly what height you do these things at, but a little bit of forward thinking, I guess. Okay. So the insert absolute allows us to put points in relative to points in other layers, which is a great little command. Okay. And then the same deal, just working my way out at what offsets I need to insert to build up my horizontal part of my grid. Okay. And naming the points appropriately so I know what they mean later on. Okay. So we can see our little grid starting to take shape here. Okay. Okay, so that's relatively straightforward. So the one that I have done, which may be a slightly different use of a command that you've probably used already in different situations in the surface, was how do I deal with, in the widening situation, where I want to cut back into the existing pavement material at these different sort of step offsets. Okay? And the way I kind of came up with was by using the inserted string command. There's an extra little choice here where you can tell it to stop a certain distance short of that string. So it doesn't have to just match exactly on it, it can stop short a little bit. Okay? Now, which string are we talking about? So what I've had to do is draw something in the plan view that just traces along the edge of the existing road, or perhaps along a sort of a nominal saw cut line, whichever line you decide represents the ultimate edge of your pavement. So let me just diverge it just slightly. So I do have a string that I've just traced along the existing road edge. All the levels of that string are the existing road levels. All right. Okay, now this is only happening at the start and end, or between the start and end of my first widening area. So if I want to be able to see these things, I just need to profile the appropriate cross section. So I come back to say change 460. And when I apply this design now, inserted my first little construction point 450 mil back from the edge of the road pavement. And then it's just the same thing for another couple of points to define this grid. So I can insert a point 300 mil stopping short of that construction line, string I should say, and another one 150 mil back. So when we go through and apply this, now created a series of construction lines at the various setbacks. Alrighty. So then there's the same deal in my second widening area. Exactly the same commands, same point names. Okay. I like to keep the same point names coming through. It means you can sort of reuse the same things in your commands, copy and paste and all that sort of thing, just in a different change range in my second widening area. Okay. So just to show what that second widening area actually is, if we jump to change 840, there's nothing there at the moment. Run this new function, MTF I should say, and now I've got my series of construction lines for this part of my little pavement grid. Okay, so with all that construction in, it's now just a case of intersecting the various heights and the various widths to construct the points that represent the actual pavement itself. So just collapse up that region so it's a bit easier to get at, and here we start building the true model itself. Okay, now because this is going to be a stepped situation, the bottom of one layer is not necessarily the same point as the top of another one. So I'm creating, with the intersection command, excuse me, I'll just turn that back on again. With my intersection command, creating a link that sits at the top of my DG28 layer, which is by intersecting my construction DG14 depth at the road grade with my construction line of a 450 mil cutback as a vertical. So we're taking our road surface slope, that 2.5%, intersecting my construction DG14 point at that road grade with my cutback 450. And then the point immediately below that, probably could have done it with an insert absolute command, but easier just to use the intersect because I can just copy and paste and then just change something. And the only thing I had to change was the construction point and the name of the link that's being constructed. Okay. So a big fan of copy and paste, means I don't have to keep typing in new things all the time. Okay. So as we're running this, okay, all these points are going to turn up on a model. I'm going to put them on this RSO1 temp so I can see what's going on. Should already be on. Not quite sure why those points haven't turned up. Because that's only area 1, and area 1 is down the other end of the job. There's always a reason, just got to find it. Okay, so here's my new points for the top and base of my DG28 layer at my cutback. So exactly the same situation for all the others, just simply intersecting the different depths with the different offsets, different widths. So my cement modified, putting it on a new layer, creating a point at the base, and then another point at the top. And again, the only difference being the depth that is my road grade is being projected through to find the intersection point. So as this starts to develop, you can see we're starting to create the top and base of my type 2, the top and base of my cement modified, top and base of my DG28. Haven't bothered doing anything with the DG14 at this point because it's going to go all full width of the final road surface anyway, so that doesn't really apply to a widening situation. Okay. So that's at the first widening area. Exactly the same thing for second widening area when I get to it in a minute. But between widening 1 and 2, we have some full width pavement. So this is creating points directly underneath the hinge where I'm building a full pavement this time. But I'm still going to construct the top and base of each individual layer. Again, the reason being is when I use my shape commands to join all these points together into the tri-mesh, into the final thing, the same points apply to the full length of the job, so I don't have to start and stop different shape definitions, different tri-mesh definitions. Okay. So again, it's just a case of doing some direct insert absolutes in this case because it's all directly underneath the hinge, my centre line, just at the depths that make up the various pavement layers. So nothing particularly magical or outstanding in that. And that is the whole thrust of this thing. I'm trying to find nice, simple, easy to use commands that construct these points wherever I need them. Okay. So if I go now and have a look at, say, change up 600 or something, where I'm building some full pavement for all my construction points. So some of these are duplicates. Okay. The DG28 is also the top of my cement modified. The cement modified is also the top of my type 2, etc., etc. Okay. And in the second widening area, exactly the same commands as the first one. So quite literally, once I had this working, I just copy and paste that whole block of commands and just change the start and end changes to the other alias of the second widening. So I can simply pop those on, apply it, go and have a look at what's happening in that sort of chainage range, and it's constructed the insertion points at the cutback steps. Okay, so that's where things are chopping and changing when you've got widening the full pavement and so forth. Behind the curve, it's going to be consistent over the full extent of my curving channel itself, but exactly the same commands, just simple intersects, simple inserts to find where these various points need to be. So at the depth of my DG28, but at the offset of 150 mil behind that curve, finding the intersection point down here. And again, just working your way out the different steps with the different points. Again, creating top and base points for each layer as needed so that my shape commands can just apply as a constant all the way through. Okay. So those little white links there, I probably should have done a duplicate on that little construction line, but don't really need to. I can just use that in my shape in just a second. Okay, so once we have all the links that we need, we could probably turn those temporary construction of all those links off. We don't necessarily need them anymore. What we do need is to join them all together into our tri-mesh shape so that we can then get volumes and all that kind of stuff. Okay. Right. So simply joining the dots, my DG14 point to my construction DG14 point, up to the carriageway and onto my construction hinge. So that's the construction hinge I did right at the start of all this boxing. simply so that we've got something to join into for this shape. So we can make him active and apply. And we have our DG14 layer going right across. DG28's got a couple of extra points in it because it's wrapping around the base of the curve, up to the back, along to the point of the curve, back up to the DG14. So joining a few different points together there, a mixture of construction, curve, and actual DG28 layer points. Just working my way around the shape. So joining the cut. The fact that they're cutback strings doesn't matter because they're exactly the same name as they are in the full width pavement. So the same shape command works for both. Trying to keep things as simple as possible. And the same situation for the rest then. Simply going through, finding what points need to join to what. Just a simple 4 points to define this shape. And we've built up our model. Yeah, so simple commands, but using them in a way where we can construct pretty much anything we really need to. And if we want to just have a little bit of fun, we can go for a drive under there. And we can see how that shape then changes from our widening area to our full pavement. And then it'll go from the full pavement back to a widening a little bit further on. Okay, maybe quite a bit further on, but it will get there. Okay, so it's just going to follow the shape of that existing edge of pavement string that was drawn up in plan, whatever that may happen to be. And as I said, with the using a string to define the extents of your work, if I decided that my widening needed to come a little bit further along the road before I went to full length pavement, then it's simply a case of picking that string up, moving it a bit further down the road to whatever change I want it to be. Just as a little tip while I'm doing this, there are some interesting little tentative picks you can do where you can pick exactly what that change is. So when placing on the alignment string, if I said I wanted to go to exactly change 535, just with a single tentative click right mouse button, you can come down to say I want to go to a particular change along that string, 535, press enter, and press enter again so it accepts that point, and that's where you've moved it to. And you can always just make that string a little bit longer or shorter so you can see it nice and clear. But it means that all the MTF the change ranges are now all fixed up the next time we recalc it. It's just using all this new thing. So if I have a look at change 520, it's using the widening techniques, and when we get up to 540, it's into a full pavement. So very easy to modify just exactly where these different things are happening with that alias idea. Okay, so a couple of other examples that I wanted to look at. The other one being the cut-off wall situation. So looking at creating something like this where it's just a vertical wall, but with very stringent requirements on how I was asked to position this thing. The top corner had to be in line with the topsoil layer, where it intersected with an RL of, in this case, 2.3. The base of the wall also had to be 500 mil below the invert of the drain itself. Okay, so a few little sort of criteria there that had to match to make this thing happen. And it actually turned out to be a lot simpler than I thought, which was very pleasing. Anyway, so I'll just get out of this one, just get this stuff out of the way for a moment, and bring the creek information back up. Okay. Okay, pop open the NTF for this one. And again, this is just a cut down in 3 I've taken a lot of the really nasty complexity out of it. Alright, so firstly, just doing the basic surface as you would normally do. So a few insert commands. Didn't use a template this time. Template didn't actually help me. Just inserting a link running along the toe of the embankment that I was going to create. Yeah. Then the interesting one was how it created the top of the embankment. Yeah. In this case, what we're actually trying to achieve was the maximum amount of usable open space, I guess, park, picnic corner area. So by having a string draped along the limits of the area that we had to work with, running a insert crossfall command to create a link at the intersection of slopes of a 1 in 4 from the edge of the drain to a 2% slope passing through that string, a construction string. So a little bit like the edge of pavement string that I drew before. Drew a string along the edge of the extent of works, draped it onto the tin, and passed a 2% slope through it, and wherever they met, that defined the top of the embankment. Yeah. And then a simple insert at string onto that construction string that's running down that edge to finish the cross-section off. So gave quite a nice result there. Yeah. So that doesn't look like 2% on that cross-section, but that's because I asked my intersection to go normal to both the lengths. So the 2% is actually perpendicular to that construction line, not just measured along the cross-section itself. Anyway, putting that aside, getting into how we actually form what's going on underneath the surface here. Again, we need to have a couple of name grades. So in this case, a name grade for the batter slope, and then another name grade for the sort of park / usable area, whatever you want to call it. Yeah. And just defined by the links that were created. So the first thing was to get the subsoil layer in, because my cut-off wall is kind of relative to that. So that had to be modelled anyway for volumes and all the rest of it. And this time putting things onto a soil layer within my MTF. Okay. And a slightly different use of the insert absolute command this time around. When I was doing the road pavements, I was just inserting points vertically one under the other for the various depths of pavement. This time I'm using the named grade as my insertion grade. And the reason being that I want to achieve a true thickness of the layer of topsoil that's going to be laid through here. Okay? So my height of 0.3 is actually measured perpendicular to the named grade, measured from that toe of batter on the right hand side. Okay. So just run that one through, and I should have done a profile model string, so I don't have to keep picking that all the time. So just pick one random. Okay. So creating a temporary strings for my cut-off wall, I didn't create some temporary strings for the soil layers. So I could simply copy and paste that one, because I'm quite happy for this to just go onto a temporary model. That doesn't really bother me at all. Using anything that I find in that soil layer. Try that again. And I've got a point inserted perpendicular to that batter slope. Okay. Now, same sort of deal. Inserting a point perpendicular to my park surface out at the edge of the park on the right hand side. Different thickness this time though. We wanted 600 ml of soil under here so we could plant some nice trees and turf and so forth. But again, perpendicular to that named grade, so getting a true thickness of this slope. Lots of little point on the outside there, and then a simple intersection between the top point, or creating a top point, I beg your pardon, intersecting the toe of the batter with the edge of the park on the right from my soil layers. So 300 down on the batter, 600 down on the park. Creates the point, well, kind of in the middle. So a little bit further down the slope because it's 600 mil below the park and 300 mil below the batter. Okay, now, if we wanted to, we could turn that into a shape. Okay. This time I was just going to leave it as a open shape, so I haven't ticked the closed box. So it just looks more like a cross-section rather than actual filled-in solid model. So completely your choice, depends on what you're actually trying to get out of it. Okay, now, this is where the slightly interesting bit comes into it. One of the things that I kind of stumbled across was that with the normal modifiers, where you're modifying widths and heights and crossfalls and so forth, they need a link to be relative to, so that those adjustments actually mean something. Okay. So what I had to do to get this modifier to the RL that I was chasing, I first had to have a link at the toe of the batter itself, so that my new link could then be modified to the height I was after. So I'll just go through the process to show what happened. Okay, so the first one, inserting a point at the toe on the right hand side on a new layer. So this is my cut-off wall right hand side, is my layer name. Again, perpendicular to the batter slope, but relative to that soil toe of batter point. Okay, so 0 width, 0 height, sitting right on top of that soil point. Yeah. So we should have a little purple dot turn up there if I've got the layer turned on. Or right hand side. Probably got two points right on top of each other. So I've got a soil string and I've got a toe right. So the TOER, that's it, and the purple string. So that turned up exactly on top of that point. Then an insert into that same layer of my cut-off wall top right point. So ultimately this point is going to end up here somewhere. But to start with, just a generic width that doesn't actually really mean anything at this point, but perpendicular to the batter slope and relative to my original point. Okay? So the whole idea of making it relative to this point is that I can then modify widths, heights and things. If there's no point there, it'd have nothing to calculate those widths and heights from on that layer. That's the critical point, it has to be on that layer. Okay. So first time through, it just creates this point kind of in no man's land to a degree, but it's on that batter slope. That's the key point there. Then to get that to the correct height, by doing a link to RL modifier to the RL of 2.3, because it's already on that slope, then I'm just adjusting that height, but keeping the crossfall that it was inserted with in the first place. So we can virtually slide that point along that batter until it gets to the RL that I was after. Okay. So in this particular example, that RL is because there was some contaminated groundwater that came up to a certain height, and we needed to put this wall in to keep that groundwater away from our excavation. That was the whole point of this cut-off wall. Okay, so that's the height that I had to achieve to keep this contaminated water back. Okay. And that's the whole sort of tricky part of it. The rest of it is then just a case of inserting the various points that are needed to build the trench itself. Again, using exactly the same simple commands that I've been using all along in this particular session. Okay. So an insert absolute from a cut-off wall top left. Notice you can use a negative width. So even though this is going from the centre line out from left to right, I'm pulling this point back towards the centre line by a distance. Still putting it on the same layer and relative to the cut-off wall top right point. Okay. And apply. And I now have my top point there. So the other part of the criteria was that the base of the wall had to be 500 mm below the drain itself. So with our insert intersect command, out of the boxing group of modifiers, creating a base left point as a vertical calculation through my top left, and a horizontal but with a negative 0.5 height difference, so dropping it below the toe of the batter on the right hand side from my design surface. And same situation for the base right point. So vertically through my top right point, 0.5 metre horizontally from the toe of the batter on the right hand side. So it creates all the various points that are required. And now that we've got all our points, we can simply join them up with our tri-mesh shape. Okay. Just working my way around the 4 points of that. So we now have our true, proper shape object as a wall modelled in, which we can then get the volumes in terms of how much clay or concrete or whatever material is going to go in there to form this wall. And it's a true model. And it's a model that adjusts itself, so if we have to change the design, it just recalculates all the criteria again and puts it in its new position. Okay. Now, the one last thing I was just going to do a quick run through is one of those things that we've sort of been trying to do over the years, and it's always been a little bit tricky, and that is to come up with an actual model of a concrete block retaining wall. Now, unfortunately, there's no magic bullets for this one. You still have to do some work, and the MTF does look a little bit interesting, but it all will make sense very soon. The main trick to this one is that when you do put in your alignments to represent the levels along the top of the wall, the levels along the footing, along the base of the wall, is to use named parts on, well, virtually everything that you can find. And in this case, that's basically all on the vertical geometry. So I'll just quickly pop one of these open so we can have a look at it. So in my part editor, the horizontal is not much, it's just a straight line, but the vertical geometry is named parts everywhere. So top layer 1, top 2, top 3, top 4, etc., etc. And likewise in the base alignment string, level 2, level 3. Okay, really imaginative names, as you can see. I try and keep them short and sweet. But the point is that they're there. And when the names are there, we can use them in our MTF file. Okay. Now, they do get used in a couple of ways, so we'll work our way through this thing. In terms of actual commands, there's only a couple here which is any different that I've used in the previous examples, so this won't take very long. But using layers quite extensively, all sorts of layers in all sorts of places so that we can do lots of construction. Okay. So firstly, just an insert absolute exactly along our hinge. Now my hinge is the alignment that's running along the top of the footing here. That's my reference for this apply function. And the idea of that is, again, so we've got something to join up to when we build our shapes for our footings or whichever point it represents. Okay. Now, also inserted a link at the alignment that runs along the top. Okay. So an insert of a 0 along the base alignment, an inserted string for the top alignment. Now, what this allows us to do is to then have, not only we're kicking off the points that we need to build our model, but we can start running some decisions too. So, because with a little retaining wall like this, you're going to have different size footings depending on the height of the wall, I'm running a series of decisions to test what the height difference is between the link that I inserted that's running along the top and the alignment string itself. Okay. So when the height difference, so that's the footing top is what that FT stands for, so that's the top of my footing. So if the difference is greater than 1.3, then I go to the 1400 high wall section of the MTF, and likewise working my way down. So as it gets closer and closer and closer, then I'm going down to the different parts of the MTF. Okay. Now the actual numbers in terms of the size of the footing and so forth, because this wall was relatively small, I was just using a standard drawing supplied by Brisbane Council. The structural guys have put together just a good standard sort of wall, so we don't need to get structural design all the time for these little ones. Obviously it's a big one that have to be designed properly. So then in the various sections, there's the label that my go-to statement for my decision set to go to, with just simple insert absolute. So it's all just width and height depending on how wide the footing needs to be, how wide your blocks are, how deep the footing is, just inserting points onto the different layers at whatever widths and depths are required for that size wall. And all those numbers, as I said, just come straight out of the standard drawing. And then at the end of it all, we just join those points up. So once you've got one section kind of sorted out, then it literally is just a copy and paste down to the next group, and then just tweak whatever the numbers apply for the different height wall. Slightly different width base, slightly different thickness of concrete perhaps, whatever. Okay. So just straight insert absolutes, there's nothing particularly crazy there. The one bit where it does get slightly interesting is we don't just normally have a straight vertical step in the footing itself. I'll just turn on the wall strings here just for a second. Just got to find them. Okay. You generally have to have a bit of an overlap from the previous, or from the next footing thickness down in this case, because it's dropping as it's going along. Need to sort of pull that depth back a little bit so we don't end up with this sort of shear plane of a vertical change. Okay. And that was done just using a simple height modifier down under the general fix-ups here. And this is also where your named parts really start to come into play. Okay. So with this fixed to 2 heights modifier, and using the type of position pushed backwards. Okay. So I've gone to my end chainage, which is just beyond, just move this over here a little bit. Okay. So going just beyond the end of my first level a little bit, finding that level and pushing it backwards to a point 300 mil before the end of that named part, before the end of that first level. Okay. So with this, I was able to get that sort of extra thickness where the footings step from one level to another kind of thing. Okay. So position backwards, very, very handy, but you really need to get those named parts in there, otherwise you're going to drive yourself mad, keep having to modify the changes all the time with these different different parts. But then once you've got one of them sorted out, it is just a case of copy and paste, work your way through all the different levels, so level 2, level 3, level 4, getting all these points just from a little bit beyond and pulling them backwards. Okay. So plenty of them, it all just depends on how many steps you've got in the footing, of course. Okay. And at the end of the day, just a case of going through and joining the dots. So all those points that were created, okay, the wall back, the wall top, all that kind of thing, all the different layers. And tend to created a lot of different layers in this situation because I had a lot of things all happening in different places. Just made it a lot easier to get my head around. That was the top of the wall, the base of the wall, top of the footing, base of the footing, all those kinds of things. So all broken up into different layers, just to make it simpler on myself, to be honest. Okay, and then when that all runs through, it creates an actual proper model. Now, why would we bother doing this sort of thing? Well, in this day and age, we have to be very, very mindful about service clashes. So again, in this case, I was able to then have my electricity conduit modelled up as my standard depth down from the surface. Yeah. So whatever it was, I think it was 900 mil or whatever it was, the standard depth down from the footpath. And because we're able to check that we're not actually clashing with these footings. Especially when wall sizes start changing dramatically and the footing width starts pushing further and further out into the road, sometimes it could actually start to conflict with something you didn't really expect until you actually get the model in there and can see it properly. Right, well that's the end of my part of the presentation. Back to you, Lisa, and if there's any questions, fire them through. We've got a couple of minutes left, I think, so here we go.
Thank you, David. Everyone seems to have absorbed this presentation really well today, and actually the main question has been, where can I get this later, which I will get to in just a moment because I think everyone's obviously really enjoyed it. The recording of this webinar will be available in coming days through our website and our YouTube channel. So I think that answers that. Our next 2 training webinars will be attributes, what they are and how to use them, on the 29th of June, and fast methods for calculating overland flow on the 12th of July. We'll also be continuing our Industry Solutions webinar series next week with a great presentation on 12DA library storage basins. So do see our website for details of all of those. We'll keep updating it with many more topics in coming weeks and also keep you posted through email and social media. And as you may know, we've also got our next 12D International Conference this July, which is drawing ever nearer. So if you haven't registered, jump on our website after this and book your place. If you need to contact us in the meantime, our details will be on the screen shortly. That concludes our presentation for today. Thank you for attending, and we hope to see you at future webinars.